Okay, lesson 2.7, graphing inequalities. Oh yeah, you did this in Algebra 1 as well. X minus 2y is less than 4. If you see this, first we got to get it graphed on the graph. There's even a note up here so we all remember it's a dashed boundary line because of this. If you see this or this, you have a dashed line or boundary in this case. If you see this less than or equal to or greater than or equal to, then you have a solid boundary or a solid line. Since this is just less than, then I will be putting a dotted line in. And I often forget. So I have to be really on my toes to watch out for that so I don't make that mistake. Now, how am I going to graph this? Well, it's a standard form. Let's go with our standard form procedure. 0 blank, blank 0. If I put 0 in for x, then I have negative 2y. And you guys, I'm going to change this to a 4. Or equal to, I mean, instead of less than. Because we're just finding the boundary, and that's where it's equal to 4. So I would have to say y equals negative 2. Over here, I'm putting 0 in for y. So now x is equal to 4. So 0, negative 2, and 4 is 0. Those are our 2 points. I'm going to make the line. Notice how I'm making it a dotted line, a dashed line. And then the test of all tests, we need to decide which side to shade. So anytime you have an inequality, you're going to be shading on a coordinate graph, the Cartesian coordinate plane. So what I usually do is test a point. I can test any point on this graph, but my favorite point, 0, 0 is the easiest one to test. So I put 0 in for x, I put 0 in for y, so minus 2 times 0, and I'm going to find out if that is less than 4. Well, 0 minus 0 is 0. 0 less than 4, well, that's a true statement. If that's a true statement, then this point right here is a true statement. And granted, we could try lots and lots of points, but all the points on this side of the dotted line are true. All of these down here would be false. Let's just test a point. You don't have to write this down. 4, negative 2. Let me try 4, negative 2. That means I put 4 in for x, and I put negative 2 in for y. And I'm going to check it out. 4, this is actually plus 4. Is that less than 4? Is 8 less than 4? No. This point is then false. All of the points on this side are false. So what do? I shade the true side because I'm saying, hey, all of these things are answers. I don't stop at the x-axis or the y-axis. And technically it goes beyond the graph paper, but we got to stop somewhere. And that's your answer. That's a visual answer of what you got to have. Okay, which graph is the graph of 2x plus 5y is greater than 10? Well, I've got 4 choices here, and I get to pick. First of all, I notice there is a greater than, but not greater than or equal to. So automatically I have solid line. This is not, automatically I don't have a solid line. So C and D are going to be out. So I'm just working with A or B. Well, I've got shading on this side of this one. I've got shading on this side of this graph. I'm going to test a point. I'm going to test 0, 0. If I put 0, 0 in, this gives me 0 greater than 10. This is a false statement. That means 0, 0 is false. If I put false over here, that wouldn't make any sense, would it? Because this is true. I need the statement that says 0, 0 is false. So this is my correct answer. This will not work. Example 3 here, y is greater than 1/3 x plus 5. So we're going to start at the very beginning. This is in slope-intercept form. 5 is my y-intercept. 1/3 is my slope. Rise 1, run 3. Rise 1, run 3. This means I have a, not a solid line, a dotted line. And now I'm going to test 0, 0. I put 0 in for y. I put 0 in for x. 0 is greater than 5. That's false. This point is false, which means all of these points on this side are false, which means all of these points are true. We shade the true side. This is example 4. One tutoring company advertises that it specializes in helping students who have a combined score in the SAT that is 900 or less. Write an inequality to describe the combined scores of students who are prospective tutoring clients. Let X represent the verbal score and Y the math score. X is the verbal part of the SAT and let Y be the math part. Since the scores must be 900 or less, use the less than or equal to symbol. Okay, they put all of a sudden out of here an are at most. I just left it up here so you can look at it, see it's all worked together. The verbal X plus Y, your verbal plus your English, or excuse me, verbal plus your math is less than or equal to 900. Okay, this continues on to the next page. I should have said, don't write all this down. You can go right here to this inequality. X plus Y is greater than or equal to 900. Let me double check, make sure I got that right. Okay, let's get that graphed, because the question is, does a student with verbal score of 480 and a math score of 410 fit the tutoring company's guidelines? Okay, if I were to graph this, 0 blank blank 0, if I put 0 in for X, oops. There we go. 0 in for X, I get 900. If I put 0 in for Y, I get 900. So I'm going to put a point at 0, 900, and another point at 900, 0. And I go ahead and connect this with a solid line. Okay, because the boundary is included in our answer. I test 0, 0. So I put 0 in for X, 0 in for Y. Is it true? Yes, 0 is less than or equal to 900. So all of these points underneath are a point of solution. And actually, this case, we really shouldn't shade beyond the X and Y axis, because could you really have a score of negative 100? And don't make a joke. Oh, yeah, I could. No, you cannot have a score of a negative 100. Okay, so the question is, does a kid with a score of 480 on the verbal, so 480 is right around here, and a math score of 410, oh, it's right on that line, isn't it? Do they fit the tutoring companies here? So even if I put 480 and 410, I added up, I get 890. I would still be under the 900 mark. It's really, really close, but I would be in that shaded region. Okay, absolute value graphing. Holy cow, there's just so much. All right, y is greater than or equal to x minus, the absolute value of x minus 2. Here's what we're going to do. We're going to make a table of values. We have to realize, and I could go into greater detail, but the phase 5 might not be good enough. So I'm just going to go down here, because I might have to add some points here. So negative 2, negative 1, 0, 1, and 2, and I might have to add points on here. We have to recognize every time you see an absolute value graph, you get a V-shaped graph. You get that flock of geese flying south, or whatever it is. All right? With that said, you have to make the graph until you see the V. Otherwise, it'll look like a linear or just a partial V. So if I put negative 2 in, what's the absolute value of negative 2? 2. And then I take 2 minus 2, I get 0. Okay, and once again, I'm trying to graph the boundary here. Negative 1. Well, the absolute value of negative 1 is 1. 1 minus 2 is negative 1. Okay, sometimes kids think, oh, I can't have a negative answer. This part can't be negative. Remember how this came out to be a 1? 1 minus 2 is still negative 1. If I put 0 in, the absolute value of 0 is 0, and then I got a negative 2. Do not pattern out. You're looking for a V in here. Somewhere it's going to start becoming symmetric. 1, absolute value of 1 is 1. 1 minus 2, that's interesting. That's negative 1. I think I'm coming full circle. All right, and then I put in absolute value of 2 is 2. 2 minus 2 is 0. Believe it or not, I have negative 2, 0, negative 1, negative 1, 0, negative 2, 1, negative 1, and 2, 0. That is enough to show me that I have a graph that has made a V. And then using pattern and symmetry, I can say, hey, this probably goes like this. Okay, remember any graph, table of values, table of values, table of values. What else do I want to say about this? Not a dotted line. Notice how there's a solid line under here. So I'm going to have a solid line when it comes to my absolute value graph. Okay, and that's a V-shaped graph. What still do I need to do? I've got an inequality, so I need to shade. So I put 0, 0 into the inequality and find out if it's true or not. Is 0 greater than or equal to negative 2? Yes, it is. So this point right here is true, which means I'm going to be shading everything on this side of the absolute value. Okay. All right, let's check here. We got y equals absolute value of x plus 3. Please notice all 4 of these graphs are the exact same graph, so I don't need to make a table. I'm not questioning the actual graph itself. I need to find out what kind of shading and where my shading belongs. All right, if I look here, it has to be less than, which means I have dotted boundary or a dashed boundary versus a solid. So I can cross off A and D right away. Now I just need to test a point. I'm going to test 0, 0. Test 0, 0. 0 less than absolute value of 0 plus 3. Is 0 less than 3? Yes, it is. So 0, 0 is a true point, but here I have it listed not shaded, so I'm saying that's a false point. Here I got 0, 0 is true, and I have it shaded, so B is the correct answer. Okay, graph y is less than or equal to 3 times the absolute value of x minus 1. Here we go again, table of values. The only thing is we got to keep our mind open. We got to find that V in our graph. So if I put negative 2 in, let's see what this comes out to be. This is 2. Absolute value of negative 2 is 2. 2 times 3 is 6. 6 minus 1 is 5. So I'm going to graph negative 2, 5. Negative 1. 3 times absolute value of negative 1 is 1 times 3 is 3. 3 minus 1 is 2. So I graph the point. Negative 1, 2. 3 times 0 minus 1 is negative 1. So I have a point. 0, negative 1. I put 1 in. 3 times the absolute value of 1 is 3. 3 minus 1 is 2. Oh, look. This is working out nicely again. And then I have 3 times the absolute value of 2. 3 times 2 is 6. 6 minus 1 is 5. I have my symmetry. I graph 1, 2. I can graph 2, 5. If I needed to, I could keep going because, have you noticed, this has like a slope of 3. A slope of 3. I would keep going. Kind of funny because it looks like I have a slope of 3. It's just an absolute value. All right. Enough with that. Solid line or dotted line? Ho, 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 ho. That looks solid. How am I going to decide which point to shade? Well, generally we say 0, 0. 0, 0 is right here, so it's within like the V-shaped portion. I do want to state, however, if your graph falls on 0, 0, just pick a different point. We just like 0, 0 because it's easy. You can pick 0, 2 if you wanted to. So I put 0 in here. I put 0 in here. I'm finding out if this is true or false. This is 0 minus 1. Is 0 less than or equal to negative 1? No. 0 is greater than. Think of a number line. It's greater than or equal to negative 1. So this point right here is false, which means all of these points outside of this area of the absolute value are true. So that's our answer, is on the outside of the V. And that ends Chapter 2 videos.